Hey, George, you're a scientist.
I'm a chemist, yes.
Right, you're a scientist. So let's say I wanted to drill a hole through like a planet. Like I'm on one side, right? Kind of that old joke of like, you can dig to China, right? So like I'm on one side
Mhm.
of the planet. I want to dig a hole to the other side of the planet. And this actually, I was thinking about this because someone in our Discord asked about this. And I was like, oh, this is now a question that I can ask you. So on behalf of Discord, if I wanted to drill a hole through the planet, like what kind of problems would I have to encounter? Because I assume this would not be a smooth endeavor.
Well, Lyons, I'm a chemist, not a geologist. But with my very limited knowledge and very limited area of expertise, here are my thoughts. So the crust is about 100 kilometers deep, right? Goes 100 kilometers down, right? The mantle,
crust material would be made up of
dirt,
dirt,
rocks,
rock, okay,
people.
Yeah.
I mean, we put people in there.
Snitches.
Yeah. Yeah, they don't just get snitches. Some of them get put up to 100 kilometers under, but we don't put them deeper than that.
No deeper.
The mantle, which goes from 100 kilometers to about 2,900 kilometers, the outer core, which goes from 2,900 kilometers to 5,100 kilometers, and the core, which goes from 5,100 kilometers to about 6,378 kilometers.
Okay, I know the planet is big, but
it's big.
But going from like, oh yeah, this first layer, it's 100 kilometers deep, and you're like, oh wow, 100 kilometers, and it's like, and this next layer is 2,900 kilometers thick, and it's like, oh, that first one wasn't that big.
And to be fair, though, we have already done extensive effort to drill a hole. We actually, as humans, spent about 20 years trying to dig a hole in Russia, and you know how deep we got it?
I'm going to say 25 kilometers.
12.
Damn it.
12.2 kilometers deep, which is 0.1% of the way there. So we got some work to do if we're going to get all the way through.
I'm confused that someone actually tried to take this on.
I mean, the weird thing, in my opinion, about science is that, a lot of times, like, you gain knowledge and you do things because you're like, hey, one, what are the constraints we're going to hit and can we overcome them? And even though you may not drill to the center of the earth, right, some of the technologies and sciences that you build along the way are super helpful. And then also some of the information you can get along the way where you're like, well, we made these assumptions, but even though we only got 0.1% of the way there, were our assumptions true thus far, So all good stuff. But yeah, somebody did attempt to drill a hole. So this is where I got to say, I am of course out of my wheelhouse, as I usually am. I'm particularly not strong in geology because my father was a geologist, and I famously did not like geology as a kid. I do remember at one point he was saying, we were out hiking, and I enjoy hiking, right? I was a teenager, so I was kind of a professional jerk, which is, as most teenagers are. And he said, hey, George, come here real fast.
We established earlier that being a professional means you're getting paid to do it.
I got an allowance.
Yes. Okay, good. So you were a professional jerk. Carry on.
Yeah.
Sorry.
Yeah. So basically, I was, kind of walking and my dad went off and goes like, hey, George, come here. And I was like, okay. So I turn around and he's going to show me some dumb rock, and then I know that, right? So I'm kind of meandering back. He's like, no, George, come here quick. And I was like, it's a rock. It's been here for millions of years. It's not going anywhere. This is the most boring science in the world. So no offense to any of our geologists out there. I have a lot of respect for it now. And also too, but
this is jerky teenage George.
Yeah, this is jerky teenage George, but I do think that it did have something to me going into chemistry, which is the study of the science of change, right? Where it's like, look at all these big explosive reactions. It's like, yeah, none of those boring rocks. Anyways,
and a lot of chemistry can be used to dissolve rocks.
Yes, so it's like, take my thing. So I play rock paper chemistry. So, anyways, from what I can tell, is there's three main problems that you run into in decreasing order of how much I research them, which is temperature, fluidity, and gravity. So the first thing is temperature, right? So as you drill down, it gets hotter, right? And it does that. So what I did was I was like, okay, let's think this through. The highest melting point material, right, is or metal is tungsten. Which do you know what the chemical symbol for tungsten is?
I want it to be like a Times New Roman capital T, but I don't think it is.
It isn't. It's a W.
Damn it!
I don't know.
Science.
Because it's tungsten. It was discovered by Russians.
Yeah.
But it was,
on the original Star Trek.
Yes, we had these whatties. Now say nuclear vessels. No. So, anyways, it has a melting point of 3,422 degrees Celsius, which, to be fair, before it melts, it would lose its structural cohesion, right? But we'll assume for the sake that it could be used up to about that temperature, right? So the interesting thing is I was like, okay, all right. So making the drill bit out of that is like, obviously, right? You got to do that. But then also you need the drill shaft too, right? And if it's going to be in things that are that hot, it can't melt on you because then you've just, wasted your whole day, right? If the thing melts off. So the shaft has to be made out of tungsten too. And if my calculations are correct, I assumed that the width, the diameter of the shaft was about 6 inches, 5 or 6 inches, because I assumed it needed to be relatively thick, which is 0.15 meters. And doing the math, because again, we're drilling all the way through the center of the Earth, you would need about 17 billion tons of tungsten to get the job done.
Which even that is actually alarmingly conservative, because my stupid peasant brain was imagining like a friggin' like James, or was it who wrote Journey to the Center of the Earth? Jules Verne.
Yeah.
Right? These are my sons, Jules and Verne. That's literally why I was able to figure that out.
Nice.
So I was thinking like a craft, right? Like I'm in a cartoonish bubble with like a giant drill bit on the end. But you went for like something that's even, like a distant neighbor to reasonable, where of course you're just trying to send the machinery through the Earth, not people.
Yeah. We're not
in
trying
like
to get
a
people
diving bell.
Yeah, we're rules as written. I'm doing the task you assigned to me, which is just drilling. We're just trying to get a hole through the Earth.
Yeah, no,
right?
yours is way more reasonable.
To be fair, yours would actually theoretically take less material because you're just drilling and you don't have to have like the thing behind you drilling, but then you have to suddenly have to get like a supply line to that. Like, how are you getting fuel to it?
Right.
Yeah, so other constraints that which should actually be a good follow-up question. We should add that one to the what would you need if you wanted to build a craft to drill through the center of the Earth, right? Because that's a whole different question. I didn't answer that one. But anyways, 17 billion tons of tungsten is about 1,000 times more than all of the tungsten.
Okay. So first we have to go like mine some asteroids and other planets.
Which, I mean, at that point, it feels like if we're going to other places, it's just like I feel that any aliens are like, I'm sorry, what are you doing? We want to drill a hole, a big one.
It's because we're going to take all the planets we colonize and put them on a big skewer so that they're easy to transport.
We want to create a planet kebab. Why? We are so bored.
We've done everything else.
Anyway, so that's kind of a no-go. And that's the interesting thing is that, like I said, it's good up to about 3,500 degrees Celsius. The mantle starts at about 1,000 degrees Celsius. The outer core starts at about 3,500 degrees Celsius, and the core reaches 5,000 degrees Celsius. So even the most heat-resistant material that I could think of, right, is not going to withstand the temperature of the core, right? Because like the problem is that most of the stuff that we make is from stuff that's on Earth, and it's all liquid at that temperature, right? So, yeah, I mean, I can't think of anything that would be better than like the highest heat resistant metal. Like I can't think of any compounds, anything organic is going to melt or catch fire into sludge at around that temperature. Like I couldn't think of anything else. So then like the thing is, what if we cooled it, right? So now you've got to start again, like piping somehow water or something cold down there, right? But then you end up with the next problem, which is that, you know, like when you're digging a hole, right? The nice thing is that it's solid, right? At some point, it would be like if you dug a hole, you were trying to dig a hole on the ocean, right? Because the mantle and the outer core, I believe the core is solid, if I remember correctly. But anyways, I know the mantle's liquid, right? You know, so like if you're drilling a hole down there, you're now just drilling through this viscous, you know, material, right? Now it is
hot one.
Super hot, and it is very viscous. You know, like you could, I mean, like you can stand on lava. You know, it'll melt you, but you can stand on it, right? You know, so like if let's just say that you're really trying to like, okay, well, I'm going to pipe a bunch of water down there, cool everything down, and then drill into it. Well, that little island is going to float away on you, you know, and so that I would imagine would be a continuous issue. So fluid is one. I wrote down torque ? Because I don't know enough about this at all. Our friend Bucknell could absolutely answer this question, but I would assume that the fact that you're spinning something really high and it's trying to spin something really low, that puts, you know, rotational torque on the shaft, which would become a problem at some point, I would assume. Just like if you know, try to spin a straw near its base, it's not a problem. But if you try to spin a straw near the top, it might curve. I don't know that for sure. I tried to look it up, and then it went into a whole bunch of different physics equations. I was like, nobody has time for this. And then finally, and the most, I guess, maybe it's interesting, I'm not sure, but it is the most mundane of them, which is that once you get to the center, somehow you've managed to magically do that, and you've gotten to the center. Now you're drilling to the other side, which means you're fighting gravity.
Right.
Because you know, like gravity pulls things towards the center. So now for every 10 feet that you move, every foot that you move, you now also have to somehow push the machinery that you're pushing up. So you would effectively be trying to erect a pole, you know, like 6,378 kilometers tall, you know, which is not a small feat, right? You know, so yeah, that's them some of the problems.
So I want to make sure I understood like the order. So you got like the crust, which is like dirt and rock. And then beneath that was
mantle.
And the mantle is primarily molten rock.
Yes. It is liquid from my memory.
Okay. And then the core is mostly iron.
So there's the outer core and the inner core. And if I remember, I'm going to screw this up and I'm going to have some geologists yell at me. One of those is solid and one of them is liquid, and I forget which is which.
Okay. But so the point is like you would be going from like solid to liquid, like to go all the way through, right? You would.
Yes.
Because it's solid on the ends and there's any liquid layers in the middle. So you would be like alternating as you went through at least once or twice. So
at least, yeah.
Yeah. That's not great.
No.
But I was thinking you wouldn't really even gain any cheats by like saying, well, what we'll do is like pinch through, right? Like we'll start from opposite ends and like meet in the middle, because there's liquid layers that are not the centermost layer. Like if the outside was solid and it had a, you know, rich creamy center, then you could say, well, once you punctured the solid part, technically you did it. You went all the way through, because now the hole goes to where the liquid is, right? But you can't even cheat that way.
And I apologize. Apparently the inner core is solid, the outer core is liquid, and the mantle is a solid plastic. So yeah, more you know.
Yeah.
So that, but yes, cosign all that, and also too, I guess I did think about what if you just drilled from both sides and met in the middle? And one, I was like, well, that feels like cheating, because the question was, what would you get to drill through the earth, right? Which kind of implies you're going all the way through. But even if I was to forego that, I thought about it, and I was like, well, I don't know, man. Like, if the size of your hole is like even just 2 feet in diameter, the precision you've got to be to line those two holes up on opposite sides of the earth, like because and the amount of time and energy if you just screwed it up a little bit. I mean, you know, like that that feels like a hell of a gamble, you know? Because I mean, I played enough Minecraft to where I was underground and somebody was above me, and we were like, "We'll meet up in the middle," and we didn't meet up in the middle, you know?
Yeah, and that's Minecraft, where you literally have exact precision.
Yep.
And you can say, I will just stand still, like hand off the mouse, press the dig button, go straight down, and it still didn't work.
Yeah, so I was just kind of like, again, like with GPS and all that sort of stuff, I don't really know. But I think that
I don't feel like GPS would be useful inside of the planet. Like, I think that's probably where it stops being useful.
Right, but I figured like with like a satellite, you might be able to say like, okay, like this is exactly 180 degrees away. But yeah, man, I don't know. Like I feel like I would be more confident with me placing down like a piece of bread on the ground and getting somebody in like China to put a piece of bread on the ground and say we made an Earth sandwich. Like I'd be comfortable with that level of precision, because you could have the meats of the Earth a little bit to one side or the other, you know?
Yeah. The sandwich is a little cattywampus, but overall, it is still an Earth sandwich.
Yeah, but I mean, you know, if but to use that same analogy, right? If I were to place that sandwich, you know, on its side, and then take 2 sewing needles and try to get them to touch in the center, that feels like something I would have less success doing.
That is probably true, and also you would ruin your sandwich.
Mm-hmm. Yeah. Nobody wants to play needle in a haystack when the haystack is the sandwich you're trying to eat.
Oh, gross. Although that does remind me of another thing I wanted to ask you about.